So in this talk, I'm going to be talking about building serverless applications with flexibility and portability. Serverless is always interesting for developers because most of the times when you build applications, you just want to write the code and deploy it without having to think about how the code is running, what kind of infrastructure that you need to set up, and things like that, right? So we have a new product called Cloud Run that probably will be interesting for you. And later on, we have Christopher and Dr. Ping Hao here to share their journey, their experience in using Cloud Run in building some of the data platform that they have. So allow me to introduce myself. My name is Henry. I'm part of the Google Cloud Professional Service. My role is a strategic cloud engineer. Basically, I help enterprise strategic customers to deploy Google Cloud products and services and make them successful. So let's talk about what is serverless first. So a lot of time people associate serverless with function as a service, something like Cloud Function. But we believe that serverless goes beyond that paradigm, right? Serverless is not just for function as a service. So there are two aspects in which you can see in terms of serverless. The first one is the operational model. So what do I mean by that is that when you use serverless, normally you will not be managing your own server, your own infrastructure, nodes, clusters, and things like that. So you just need to bring your code, and then that's it. Something behind the behind the scene will run your code and make sure that it works. Implicitly, because of that, some of the security aspect is fully managed by the platform as well. So you don't need to think about lots of firewall rules or maybe patching your infrastructure and things like that. And the good thing as well, you pay only per usage. So when your application scales up, you pay as much as you use. But if nobody is using your application, you pay nothing, which is a good thing in terms of business sense. The second aspect is on the programming model. So typically, serverless application is service-based, or what people call microservices this day. They're triggered by events, so something like HTTP requests or pops up notifications and things like that. And we'd like to think that a serverless platform should be open as well. So you should not be locked into your platform provider. In Google Cloud, we have three serverless compute options. Obviously, Google Cloud has many other serverless products in data or ML. But in specific compute, we have three products that can help you. The first one is Cloud Function. Cloud Function is like a function as a service. It's an event-driven serverless function platform. It provides a simple development experience. You just write your function in the language that is supported, and then you just deploy it. It will auto-scale with usage. So the more requests that comes in, we will spin up more function instance for you. It will respond to events that is happening. So for example, if you trigger HTTP requests, more function instances will be spinned up. And then you pay only per you use, okay? Which is nice. The second product that we have is called App Engine. So App Engine is an HTTP-driven serverless application platform. Historically, App Engine is like the first cloud product that we have. And it's been helping lots of companies and products, building applications in agile manner. So some of the good things about App Engine is that first, it has zero config deployments. So if you don't need to, configure lots of things, you can simply bring your code to App Engine by running a command, gcloud app deploy. It will auto scale as well, similar to Cloud Function, and you pay only per you use. But the idea of serverless, looking at those two products, right, sometimes it's not available for everyone. A few reasons why, because sometimes they don't want to invest in new tools, because Cloud Function and App Engine, you would argue that you will have some kind of a vendor lock-in. You would have to rewrite your code in a way that is compatible with those products. Sometimes you have to use custom APIs. For example, historically, App Engine, first generation, you need to comply with how the API works. And so we've been hearing from these customers, as some of you may be in the room, that we should do more in this serverless area. And then it should be more available to everyone. Meanwhile, in the world, we all know that containers have been growing very fast. So I just took this snapshot of Google Trends a few days back. So the term Docker container has been trending in the recent years. As you can see towards the right side there, it's like reaching 100% sometime in 2019. So it's pretty popular. So that's why we built our third serverless product called Cloud Run that is based on containers. So I'm going to be talking about these three pillars of Cloud Run. So the first one is being able to bring your containers into production within seconds. So I'm sure some of you might have heard about containers, maybe also use it. So what are the good things about containers? First is that you can write your application in any language, and you can package it in the container, right? So you can also bring any libraries, any dependencies, any binaries inside your Docker container. And there are plenty of base images available out there, either in Docker Hub or some other public repositories. Even Google Cloud provides secure base images that you can choose for your applications. And lastly, more and more containers have become an industry standard for packaging and distributing your application. So in terms of step, how do you want to build your code, your application into Cloud Run? It's as simple as these three things. So you write your code, you build your Docker container image, and then you bring it to Cloud Run to run it. But there are several, so-called rules that probably you need to adopt. So Cloud Run currently only supports HTTP-based workload, and it will listen to a given port. So for example, port 8080. And then your application should be stateless. So this is also another best practice of building container-based application, in which that your application should not be stateless. Whenever you want to persist something, or states we call it, you use external database. So for example, Google Cloud has several products like Cloud SQL, earlier you heard, and like Firestore, and maybe some other database products. In terms of building your Docker image, Google Cloud also provides a serverless CI/CD platform called Cloud Build. So essentially, you can also use that serverless product to build your Docker container image. And Cloud Build itself is quite flexible. You can build advanced build steps inside the Cloud Build YAML. And you can also do the deployment after you build the application. So Cloud Build, in a sense, will be able to support a CI/CD workflow inside your development lifecycle. So then how do you run it? So once you have the Docker container image ready, probably in the Google Container Registry, you just deploy it to Cloud Run. And typically this happens within seconds, normally under 1 minute. So I'm going to show you a demo here. Is this good at the back? Okay, cool. So I'm going to use a GitHub repository available out there. So there's a GitHub repository called as a service. Essentially, these are written by Google Cloud team to showcase how easy to bring, like a code stored in a GitHub repository into Cloud Run. So if you see some of these examples and you open one of it, you will see this Run on Cloud Run button. Basically, you'll be able to click from here, and it will bring you to Google Cloud Shell, and it will deploy to your Cloud Run environment. But I won't do that. I will do the other way. So let's say I'll take this example, which is called meme as a service. Okay. So what I'll do here, I open my Cloud Shell, right? So I will do a git clone. So taking the URL here. Okay, so once I have that, I will use Cloud Build to actually run the build, right? So for those of you probably who haven't heard about Cloud Build before, Cloud Build is our serverless CI/CD platform. So essentially, once you submit your build, right, you can view how the build is progressing, including the logs that you have for your build steps. So let's wait for a while because it will be building a Golang based of service, and typically it will run in 49 seconds. So after this cloud build finishes, it will push the container image into the Google Container Registry. At the moment here, we don't have the meme container image. So by the end of the build, hopefully we should be able to see a Docker image created there. So it's almost finished now. So as you can see, it finishes and the build is green. So now if I refresh my container registry here, I will be able to see a version of my Docker container image here. So there are many ways how to deploy this container image. So for now, I'm going to use this option here where you can select a particular revision of your Docker image and then click deploy to Cloud Run. So it will populate which container image that you want. I'm going to show the first option, which is the fully managed Cloud Run. We'll just pick Tokyo, which is the nearest from here. Provide a service name. And then for this option, I allow unauthenticated, basically saying this is like a public service. And there are many other settings that you can play around as well. Like for example, if you need more memory, if you want to tweak the number of concurrent requests and things like that. So for now, I just choose the default options and click create. So as I mentioned, this process typically will run within, like under a minute. So sometimes it could be very fast. So as you can see here now, maybe within 10-15 seconds, you have a service running. So let's open a URL provided by the console here. And I'm going to use a public image that I find on Pixabay and produce a meme. Okay, it should be this way. Okay, I think it's too simple that nobody is clapping. Thank you. So as you can see, it's pretty fast to build, your container and also run it on Cloud Run. It's just few clicks. You can also do using a command line. So let's switch back to the slides. So the second thing that I'm going to talk about for Cloud Run is it is natively serverless. What do I mean by that? First is you just focus on your code, like we see just now. You just have a you just have a GitHub repository or any Git repository. You focus on that, you commit, and then basically you just say build the container. And then there's no infrastructure for Cloud Run for you to manage in Cloud Run. And we'll give you these managed URLs and SSL certificates out of the box, just like what you saw. The endpoints that I access is actually HTTPS based, and we create a URL for you. Cloud Run also handles the redundant and failover strategy. Again, it's very simple in terms of developer experience. You just provide a Docker container, and that's it. You just run it. It will auto-scale as your workload increases, and you just pay per use. I'm going to explain a little bit on these two. So I think typical, serverless platform, right, like Cloud Function or App Engine, right, we will horizontally auto-scale the number of instances that is running behind the scene to handle the workload that is incoming. So if you have like high burst traffic, we will create more instances for you. But when the workload receives nothing, right, we will scale it down up to even 0, meaning that there's no instance running at all. In terms of the costing model, so we typically charge based on the number of CPU, memory, and number of requests. And the lowest granularity is within 100 milliseconds. So if let's say your workload runs like 10 milliseconds, we will still charge you in 100 milliseconds. And you will be only billed when Cloud Run is processing one request. So let's dive deep a bit here. So the blue highlighted area is actually the time when we charge your instance. So if you see the bigger rectangular there is actually the instance time, but even if the instance is running, we are not charging you unless there's one request coming in. And the end of the charges will happen after the last request finishes. So you are not charged for like number of concurrent requests happening at the same time within the same instance. We will only charge you at the first point in time and the last point in time. So the third is about the experience. We also want to make your serverless workload portable. What do I mean by that? Sometimes when these days when people talk about containers, they highly associate that with Kubernetes, right? Kubernetes is actually a fantastic platform, but we also heard that many people sort of complains that it's too hard to manage Kubernetes clusters. There are so many things that you need to understand about Kubernetes. You need to write the deployment in a certain format in YAML and things like that. So I like this quote from Kelsey Hightower, in which he says, Kubernetes is a platform for building another platforms. It's a better place to start, but obviously this is not the end game. So we want to also introduce you to the concept of Cloud Run for Anthos. So Cloud Run for Anthos actually allows your organization to leverage on your existing investment in Kubernetes, or specifically GKE, with the development experience of a serverless. So you get all the benefits of auto scaling, including to zero container instances, but you get to leverage your existing Kubernetes instances. You also get deep integration with Stackdriver, custom hardware, and things like that. So there are two choices available for running your Cloud Run application. The first one is the fully managed, which we just saw in the demo. It's fully serverless, no cluster to manage, and you pay per use. And the second one is a Cloud Run for Anthos, in which you provide the GKE instances, but you will deploy in the same way using the same similar experience. So let me show you a demo using the same application. So if you can switch back to the demo, please. Okay, so if we go to Cloud Run, and maybe I'll refresh. Just now we see there's one service that we just deployed. So I've already created a Kubernetes cluster here. And then basically the same process. I just select the container image that I want, which we built 6 minutes ago. And then we choose the second option here, which is Cloud Run for Anthos. Right? It will automatically populate which other clusters you have at the moment. Since I only have one, let's just choose that, name your service, and say which connectivity you want. So the good thing about Cloud Run for Anthos is that you can build your serverless workloads to be available only internally. But if you choose to expose it publicly, you can also do so. And same settings here at the bottom. So let's create the service. So typically this will be even faster, because all the underlying infra is already there. Okay, so again, within maybe 10 seconds, you'll be able to see your application running. The difference when you want to access this application, right, this URL is actually a dummy URL, so you won't be able to click and run it. So for Cloud Run for Anthos, you need to do what we call the custom domain mapping. So once you have like a domain for your organization, right? This is my domain, my organization domain. I'll just create a service called meme, right? So I map it to my cluster. And then when I click this, I should be able to see similar applications. So let's just test it using, using a different image, maybe. So yeah, so we just run the same workload now in a different platform, which is our GK cluster using Cloud Run for Anthos. So let's switch back to the slides. So one thing to note about Cloud Run is that we built this service based on Knative, which is an open source initiative project led by Google initially. So what is Knative? Knative is a Kubernetes-based platform for you to deploy and manage serverless applications. So there are many companies and vendors out there also building a product that is based on Knative API. So what does it mean? It means that your workload will be able to be ported to different implementations of Knative, and you don't need to change anything. So meaning that you don't have any vendor lock-in. So if you're interested, you can go to knative.dev. So in summary, you can choose the platform for you, Cloud Run or Cloud Run for Anthos. And in terms of learning more about this product, you can go to this URL. And now I'd like to invite Christopher and Dr. Ping Hao from Sentient. They are going to share their experience, using Cloud Run, building their AI and data platform. So thank you.
Hey, good afternoon, everybody. My name is Chris, and I'm the founder of Sentient. And what we do is we want to help developers build great applications. So one of our missions is actually to reach 1 billion people with AI. And we feel that AI should benefit everybody on this planet. And so you are our partners in building this, in reaching this goal, because as programmers, we're always very busy. We're always chasing deadlines. There's always so much code to write, and yet you need to build intelligent systems. So some of us actually don't have the time or don't have enough time to start learning new tool sets, to start learning how to build AI models. So what we do in Sentient is we actually help you consume pre-trained and semi-pre-trained AI algorithms. We build that so that you can, in 10 minutes, copy and paste our API endpoint and use that in your code. It's all hosted. So our algorithms are hosted in the cloud, and then you can just very easily and very quickly use all the various algorithms that we have built for you and put them in your code to build intelligent systems very, very quickly. So on an overview, we actually have an API catalog that you can just go in there, find the kinds of APIs that you need. For example, we're going to show you a name entity extraction algorithm later on. And we also have a mix of AI microservices on the one hand. We also have public and private data sets that you can actually use in your software. So all you need to do is just register an account on our platform and you're ready to go. All of these runs on Kubernetes, and it makes it very easy for you to consume these services in the cloud to very quickly build prototypes or very quickly build systems that possess very good AI capability in there. Or the entire platform here can also sit on-prem on data centers. So if you are an IT programmer within your corporations, this entire platform sits in your data center if you want that. Oops. So here we can see two screens that we have. On the left side is a catalog of microservices. Just go in there, search for the microservice that you need, and then you can actually, if you select one of the microservice, as you can see there, all you need to do is to copy the endpoint, the security token, and away you go. So it's that simple. In 10 minutes, you're ready to run. And that's why we want to help you very quickly get your job done. We know that you're very busy. We know that you have many deadlines to catch. That's why we are obsessed at making software development for AI easy for you. But what do we do to make all this simple? There's so much heavyweight lifting behind the scenes. Our team actually identify a set of AI algorithms that we think you will need in building your applications. And then we have to build the models ourselves. We have to train the models. We have to test them. And then we deploy them. And this is a lot of work. After that, we have to expose these models as REST call APIs so that it makes your life easier because all you need to know is how to take REST call APIs into your app. And then finally, we have to make the APIs discoverable for you. So all these things we have here are all fully automated in our backend. As we run on Kubernetes, we run on containers, and we make it so easy that within 10 minutes you're up and running. So right now, we'd like to just show you a little bit about the magic that we have at the back end. How do we do all this in a rapid fashion to bring thousands of APIs to you? Bing Hao, would you like to share with them?
Yeah, sure. Thank you very much. Thank you, Chris. Thank you, Google, for giving us this opportunity to come here and share some of our ideas and thoughts about not just Cloud Run as a serverless framework, but also deploying AI. So what I'm going to do today is I'm going to do a very quick demo of deploying a named entity recognition model using Cloud Run for Anthos. It's going to be a really, really quick demo because Henry would have covered a lot of the details. But what I really want to do today is to highlight three things to you guys, right? Number one, it should be really easy to deploy AI-enabled applications. Number two, a serverless framework like Cloud Run really helps a startup like us to control our costs. And number three, how a common interface, a common framework really helps us speed up our innovation cycle. So here we go. Let's say I'm part of the science team and I develop a named entity recognition model that takes a chunk of text and picks out automatically from it what are the people's, what are the person's names inside, what are the locations inside. Then what do I do? Like Henry said, I would just package it up into a Docker container. As an AI scientist, I should have the capability to at least come up with a basic Docker container, right? No one knows better than me how to handle my model, how to load the parameters, and the Flask API that serves out the model is rather standard. So once I package it up as a Docker container, I shouldn't have to be taking care of networking, namespacing, scaling, etc., etc. What I'm going to do is I'm going to give a shout out to my platform engineer, Zijian here. Say hi. Say hi. All right, Zijian here. All right, Zijian here is going to just go to, can we cut to the demo, please, the screen? All right, thank you. Zijian here is just going to create a service like Henry has shown. Just very quickly, find the container. Rather, find the Docker image. Say that it's going to deploy it on a cluster, a very aptly named standard cluster 1. And then he's going to give it a name, a very generic name or a standardized name. And lastly, he's going to tell it how much resources he's going to use, right? Maybe say 6 gigabytes for now. Now on Anthos, on GKE, you are able to specify slightly more resources than what is available on Cloud Run fully managed. And he's going to click Create. Now, that's basically all he has to do, right? And what this then does is that a service like this is very useful for, say, processing emails, chat logs, or transcripts over at night, at midnight maybe, and then during the day when it's not being used, it scales down to 0. All right? To interact with it is just a REST API call. So we cobbled together a very simple front end. Zijian is going to put a news article into it, and then he's going to click Analyze. All right, it's a news article we plucked off the internet. It takes a little bit of time because it's a rather long article, but there you go. It picks out persons, it picks out locations, right? It's as simple as that. You know, we are so thank you, Henry. We are so surrounded by AI nowadays that sometimes the magic of AI is lost on us. You know, it's amazing that nowadays we can have computers do this automatically for us. We can have computers recognizing images for us. But it's also amazing, or almost as amazing, that all this power is now a click of a button away. And this brings me squarely to my first point, and that is building AI-enabled applications should be easy, right? This is what we believe in at Sentient. So if you're an individual developer, you shouldn't have to, you should be focusing on your solution, your app. You shouldn't have to spend your time training models from scratch. If you're a company, you should be allowing your data science team or your AI specialist to focus on the key problem statements, right? Like balance sheet optimization, contextual marketing, so on and so forth. Or maybe even your problem isn't even technical. It could be a better HR process. And you just need some AI elements to help you along, right? So let us help you in that, right? You should be allowed to focus on your solution, your analysis, your app, right? Leverage on providers like us that perhaps provide you as a one-stop shop, a marketplace, so to speak, where we host multiple AI algorithms that are not just developed by us, but also by our partners who are excellent at what they do. And then you can just and you can forget about worrying about having to employ your data scientists, train your models, and so on and so forth, right? It should be really, really easy. Number two, a serverless framework like this helps a startup like us control cost. Because as Henry said, it scales to zero when it's not used and then scales up when you need it. So this allows us to oversubscribe our hardware a little bit and potentially pass on any of those cost savings to our clients for whom we develop bespoke projects for. And lastly, having a common interface, be it Knative or other standardized frameworks, really helps reduce the operational friction between our engineering team and our science team, because everyone knows where to go and what to do. Everyone knows what to expect. For example, like just now, Zijian didn't have to figure out how in the world does he load my model, and neither did I have to figure out about the networking and the scaling. Although to be fair, Cloud Run did most of the work, right? So I want to say this one last time before I leave. Building AI-enabled applications should be easy, right? And with that, I thank you all for your attention, and I pass the time back to Alex. Thank you very much.